Great. Hi, everyone. And here we are. So, of course we will. Here we go. Comparing and ordering fractions today. What am I looking for? Well, ladies and gents, interpreting diagrams that represent fractions. I'm looking for you to find the lowest common multiple when converting fractions. Now, there's lots of vocabulary to deal with. The usual: fraction, numerator, denominator, convert. Representation and diagram I've mentioned before, and I'd like to introduce lowest common multiple, LCM, and then greater than and less than. Let's get started. Okay, let's look at the information that's been given to us. We've got a couple of groups of people. We've got group A and group B, and there may be adults, there may be children, they might be on a school trip, they might have just been dropped off on the school bus ready to go to school. Who knows? But we're not really sure. There's not much to go on there. So the question: which group has the bigger fraction of people wearing glasses? So we've got a bit more information here. So we're looking at group A, and we've got 3 people with glasses, but there are 4 altogether. We've got 3, 6, 7, 8 people in group B, of which 2, 3, 4, 5, 5 personas have glasses on. So let's have a look at that. How would I express that in terms of a fraction? Well, it's asking me, in other words, both groups, which has the most number of glasses wearers? Well, group A, there are 4 people altogether, of which 3 are wearing glasses. So expressed as a fraction, I know that's 3 out of 4, or 3/4 of the group are glasses wearers. Group B, on the other hand, it looks like there are 8 people, of which 5 are wearing glasses. So expressed as a fraction would be 5 out of 8, or 5/8 of the group are wearing glasses. But the question is asking which group has the biggest fraction of glasses wearers. Well, we can't at this point compare easily and accurately because the denominators on these fractions aren't the same. So let's find out, how do you compare fractions where the denominators are different? Here we go. So when we do compare 2 different fractions, we need to make the denominator the same. Here's the information from the previous slide, just for your information. What do I mean by that? Well, we need to compare. Which is the largest? Is it 3/4 or 5/8? And that can't be done easily at the moment. So here's a clue. Our friend here has found equivalent fractions for group A so that she can compare in eighths. In other words, 3/4 can be converted to something eighths, so that then you can compare it with 5/8. Let's have a look. So 3/4 is equivalent, the same value as 6/8, and we know this by our common factor of 2 here. So if we multiply the numerator by 2 and the denominator by 2, we end up with 6/8, which is equivalent to 3/4. And let's have a look on this fraction bar diagram. So we have got here 1/4, 2/4, 3/4, and that would be the 4th quarter. So we populated 3 out of the 4 equal parts, but in terms of eighths, apparently that is equivalent to 6/8. So let's have a look. Okay, so we've got 1/8 there, 2/8 there, the equivalent to 1/4. 3/8 there, 4/8, the equivalent to 2/4 or a half. And then we've got another 2/8, giving us the same as 3/4. So 3/4 is equivalent to, or converts to, 6/8. Now the denominator is the same as the other fraction, 5/8, represented by group B. So let's have a look. We can compare sizes. So group B, 1/8, 2/8, 3/8, 4/8, and 5/8, represented on our bar diagram here. So therefore, we can see 5/8 stays the same because the denominator is already in eighths. We can have a look now at our diagrams and clearly see the orange bar there shows that group A has a larger number of glasses wearers at this point. And you can see it's got 1/8 less here in group B than group A. So Group A has got to answer the question. 6/8 is greater than 5/8. So therefore, when we convert back, 3/4 is also greater than 5/8. So in answer to the question, Group A has the bigger fraction of people wearing glasses. Let's have another practice. Now, how can I compare the sizes of fractions like 3/4 and 2/3? Same kind of problem. The denominators are different, so it's hard to accurately compare sizes. What could we do? Let's count in multiples of 4, our denominator, and see if we can come across something, a commonality. How about multiples of 3, the denominator in 2/3? So let's have a look. We've got a multiples of 4, 4, 8, 12, 16, 20, 24, and so on and so forth. And we've got multiples of 3, 3, 6, 9, 12, 15, 18. 12. Now, 12 is what is called the lowest common multiple. It links that denominator there and that denominator there. So we'll need to convert both of these denominators into 12ths. Okay, the lowest common multiple is 4 and 3. It is 4 and 3 for 12, so we can find equivalent fractions that also have that denominator of 12. How do we do that? Right. Okay, I know that if I were to multiply the 4 in 3/4 by 3, it will give me a new denominator of 12ths. And again, I will do the same to the top. My numerator multiplied by 3, 9/12. So 3/4 is equivalent to 9/12. But the thing is, we're still not in 12ths for 2/3. So let's have a look there. We're going to use the multiple of 4 because 3 in our denominator multiplied by 4 gives me 12ths in the equivalent fraction. And what I do to the bottom, I do to the top. So 2 lots of 4 is 8. So it looks like 2/3 is the equivalent to 8/12. And now we've got an idea, 9/12 and 8/12, we can sort of compare. What you needed to do was to find equivalent fractions for both groups. And our young friend here is saying to get the same denominator, you found the lowest common multiples, which happened to be 4 and 3. Okay, both multiples of 12. So if we were to compare on a fraction bar diagram, this fraction bar diagram represents 1, 2, 3, 4, 5, 6, 7, 8, 9. 9/12, or 3/4. There's 1/4, there's 2, and there's 3. And this bar diagram represents here 8/12. So you can see both diagrams are split into 12 equal parts, and therefore now you can compare sizes. So let's just check that 8/12 is indeed represented here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12 equal parts, and there are 1/12, 2/12, 3/12, 4/12, 5, 6, 7, and 8/12. So here now we can compare. Which is greater? If we were to compare the sizes, let's have a look. 9/12 here at the top is greater than 8/12, and you can see there's a difference of a 12th there. So therefore, going back to the original fractions, 3/4 is greater than 2/3. Yeah. Okay, try this one. This time, 5/6 of a class, and it happens to be class A, have brown hair. 2/3 of class B, on the other hand, have brown hair. So the question is, similar to the glasses question, which class has a bigger fraction of children with brown hair? So you've got 5/6, you've got 2/3, and you've got two different denominators. So you're going to have to think about the lowest common multiples to then convert both of those fractions to the same denominator. So what might you do? Okay, bar diagrams are good to show what we mean. Here we've got class A, and we've got bar fraction diagram split into 6 equal parts. 1/6, 2/6, 3/6 or a half, 4/6, 5/6. Yeah, so that first diagram represents 5/6 of class A who have brown hair. So now, how are we going to show 2/3 for class B? Well, let's have a look. You have the same size diagram again, and this time it is split into 1, 2, 3, 4, 5, 6 equal parts. But you can see we're not in sixths here. So we have got our bar diagram split into 3 equal parts, 1, 2, 3, each part representing 1/3. So there's 1/3, there's 2/3. So I need 2/3. And how would I represent that as sixths? Let's have a look. 1/6, which is a half of a third, 2/6, and you can see 2/6 is indeed equivalent to 1/3, but we need 2/3. So according to this, 2/3 is the same as 4/6. But how can we work that out using the lowest common multiple? Well, the lowest common multiple of 6 and 3 happens to be 2. And let me show you what I mean by that. Because 2/3 here, in terms of sixths, you would multiply 2/3, the denominator, by 2, because to give us the, and you do the same to the numerator. So 2 lots of 2 are 4. So 2/3 is equivalent to 4/6. Yes. So now you could populate the rest of the calculation. It says 5/6, and that's looking for that little blue circle, an operation. So let's have a look. Let's see, or a symbol. 5/6, is it greater than or is it less than the 4/6 that we've converted? Well, of course, 5/6 is definitely greater than 4/6. And if we go back here to our diagrams, you can see that 5/6 here is 1/6 bigger than the 4/6 represented there. So in answer to the question, 5/6 is greater than 2/3, because remember we converted it into 6, giving class A the bigger fraction of children with brown hair. Cool. Let's have some more practice. This time, half of a class, and this is class A, has a pet. Class B, on the other hand, 3/8 of that class have a pet. Which class has a bigger fraction of a pet? Is it class A or is it class B? Same problem. 2 fractions, 2 different denominators. So how are we going to represent this firstly on our bar diagram? Well, yeah, class A represented as a half, 1 out of 2 equal parts on our bar fraction diagram. Great. Class B, on the other hand, 3 out of 8 or 3/8. So we've got the same size diagram split into 8, and we need 3 of them. 1, 2 y 3. 3/8. All right, but we still don't know how to convert a half into 8ths. So the lowest common multiple of 2 and 8, the denominators in the fractions in the question, is 4, because if we take a half and we multiply it by 4, it then converts it into 8ths. We can start to compare. So the bottom you do to the top. The numerator multiplied by 4 gives us an equivalent of a half to 4/8. So now you can see, all right, in terms of a half, it is equivalent to 4/8. So a half is greater than 3/8. Here you can see. And it is greater than 3/8 to the 2. So class A has the bigger fraction of children with a pet. Got it? I hope so. Try these. Put each of these sets of fractions in order from the smallest to the biggest. Now, my friend here is giving some advice. She says, I need to find the lowest common multiple of more than 2 numbers here. This will be the denominator that I need to compare, all right, so that I can order. If we go for question 2A, 2/3, a half, 5/6. Order from the smallest to the biggest. Little bit of advice here. All the denominators in question 2A need to be converted to sixths. And the denominators in 2B, half, 5/12, 5/6, 3/4 also need to be converted to 12ths. So have a go at finding the lowest common multiples to convert those fractions. Pause the video, see how you get on, then come back to me. We'll go through some answers. All right, so before you paused, I asked you, have a go at putting these sets of fractions in order from the smallest to the biggest. And the advice was to find lowest common multiples. Well, what do we mean by that? Well, I gave you a clue for 2a, because I know that 3, that denominator there, and 2, whoops, that denominator there, are both multiples of 6. So it looks like we can have a common denominator of 6, but how do we do all this converting business? That's where you need the lowest common multiples. So here we go. Let me show you what I mean. That question we are going to look at. The lowest common multiples, I think, will be 2 and 3, and this is why. If we take the first fraction, 2/3, and we multiply that by 2, the denominator and the numerator, it gives us a converted fraction into 4/6. So 2/3 is now 4/6. It's equivalent, the same value. What about a half? We need to convert a half into 6. Well, to do that, we multiply by 3, because 2 times 3 and 1 times 3 gives us 3/6. Now, 5/6, we don't need to do anything to that, I beg your pardon, because we've already got a denominator of 6. So now we're in a position to be able to compare 4/6, 3/6 and 5/6 in terms of the smallest to the lowest. And when you're dealing in fractions where the denominators are the same, look to the numerators. And the smaller the numerator, the smaller the fraction where the denominators are the same. So if we were to order, I can see that 3/6 is the smallest. I can see the next smallest is 2/3 or 4/6, and then the largest happens to be 5/6. But remember, we're dealing in these fractions here, not the conversions. That's, I guess, your workings out step, isn't it? So let's put these into an order. So from the smallest will be a half, and then 2/3 to the largest of those fractions being 5/6. Okay, B, can you order a half, 5/12, 5/6 and 3/4? Well, we're dealing in 12ths, so the clue said. So I think the lowest common multiples, to get to 12, I need to multiply by 6. I need to get to 12 to multiply by 2. And let's have a look at that denominator by 3. So I think 6, 2 and 3 are the lowest common multiples. Yes. Okay, let's go for it. A half converted into 12ths. I need to multiply the 2 in the denominator by 6 and the 1 by 6 to give me 6/12. 5/12. We're already in 12ths. We don't need to do anything to that. Cool. Now we've got 5/6. Right, to get to 12ths from 5/6 to convert, I know I can multiply the denominator by 2 and the numerator by 2. 10/12. Leaving 3/4. How would I convert that into 12ths? Well, I know to get to 12, I can multiply 4 by 3. Yes, in the denominator, and I'll do the same to the numerator, giving me a brand new equivalent fraction of 9/12. Now I'm in a position to compare. Here we go. Remember, where the denominator is the same, go for the numerator. And the smallest numerator is 5/12. So the smallest fraction at the moment happens to be 5/12. Let's go for the next size up. Okay, 6/12. But remember, we're not ordering 6/12, we're ordering a half. So next on the list will be a half. Then we'll go to 10/12, 9/12. But remember, we are ordering 3/4, it's equivalent. So in order, 3/4, and that must leave 10/12, or as the fraction suggests, 5/6. Goodness me. Whew, what a big job. Are you ready? Now, of course, if there's anything in that video that you're not sure about, there's nothing stopping you from pausing and rewinding, having a little look at the bits that you're not sure about, or dropping me a message. Lots to take in, I know, but have a go at the questions today from our Power Maths books. Here they are, and there are 3 pages of them. Here are the first 2, and here's the final page with the reflect, where, as always, I'm interested in your use of vocabulary, certainly the vocabulary I introduce and have used throughout the presentation today in your write-up. So try your best with that. When you have completed your work, you know what to do. Everybody needs to get back to me with a photograph so I can see how much progress you've made. If you fancy a bit more of a challenge, here it is, a tricky one where our friend in the top there is saying, I think some statements may have more than one answer. Oh, this seems like a headache, but I bet some of you out there will be able to do that. So I'll leave it with you, my friends. Thank you for your attention. It's been quite a tricky one today. Well done. Lesson 4 over. Have a go at the independent work, and I guess I'll see you very soon. In the meantime, that's Miss B signing off. Take it easy, enjoy your maths, and keep in touch. Ta-ta.